Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle. And it's called Color Me Even by Jonesy. And here are the rules. Hi Jonesy. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. We have yin-yang coloring, where we need to color each cell using two colors so that each color forms a single orthogonally connected region, and no 2x2 area contains only one color. So, for example, we could do coloring like this, where we have blue and green. That's what I usually use for yin-yang coloring. And this is an example of a valid yin-yang shading. Because to get from any cell in the blue region to any other cell in the blue region, you can just go through edges all while staying within the region. That's what it means to be orthogonally connected as a region. Right? So to get from this cell to this cell, you just go through the edges all the way here, all while staying within the region to get to that cell. Same with the green. The green is valid as a region right now too, because you can get from any cell in the green region to any other cell in the green region just by going through edges, all while staying within the region. What would not be valid as a region, though, would be something like, say, this, right? Then the green cells could not get through to each other by just getting through edges. You'd have to go through a corner or go to the other region to do that, and that's not valid. Again, that's why it's not orthogonally connected, because this section cannot is not orthogonally connected to the rest of the region. And same with this blue cell, actually. This blue cell can't get to any of the blue cells in the rest of the region just by going through edges while staying within the region. It has to go through a corner here, or it has to go to the green region through an edge and then get to the blue. So that's an example of how yin-yang shading does not work. Another reason for not being able to work would be if, for example, this was green. So even though you can get to every other cell in the green region or the blue region just by going through edges while staying within the region, this 2x2 area is all green, and that is not allowed in yin-yang shading. So those are examples of how yin-yang coloring work. The next rule set is parity counterlines. The two digits at the end of each line indicate the number of odd and even digits in that line, including the end digit themselves. So one digit counts odd digits, the other counts even. So for example, you could have something like, say, whoops, that's coloring still. You could have something like, say, 2 and 4. And then you could have, like, for example, 6 and 8, and then 3 and 5 along that. And the 4 says how many even digits there are, because there is 1, 2, 3, 4 even digits, and the 2 would say how many odd digits there are. There are 3 and 5 only, so that's 2 odd digits, right? And it can be in either order, right? It doesn't have to be one on one side and one on the other side. There's no distinction between that. So that's how parity counterlines work. We also have color parity interaction, where all digits of the same parity within a line must share the same color. Interesting. So this is not actually valid here because, for example, then you can't have... They're not of the same parity. And they would have to be the same parity if they are the same color. And vice versa. If they are the same color, they must be of the same parity. Digits with opposite parity on the same line must have a different color. Note that a digit on the end of a line does not count the amount of same colored cells. Right. Okay. So yeah, that's just basically noting that basically on these lines, the numbers count the number of odd and even digits. Obviously, if you have both of these be even on the end, then the 2 would, assuming this was correct, right? So then this would be like, this is an example of how the color parity interaction would work correctly, right? Because 2, 6, 8, and 4 are the same parity and they share the same color. And the digits of the opposite parity, 3 and 5, are the different color, right? So obviously the 2 is a different color than the odd digits, but obviously it counts only just the odd digits. It's not counting the colors, right? Or I guess it's counting the number, yeah. It's not counting the number of different digits that are the same color as it, essentially. That's interesting. So that's how these colors and parity lines interact. We also have crop key dots, where standard black and white crop key rules apply. A black dot indicates one digit is double the other, and a white dot indicates consecutive digits. So, for example, if this were, say, a 6, this would have to be a 5 or a 7 to be consecutive with it. And say, for example, this was a 2, this would have to be 1 or 4 to maintain the 1-to-2 ratio that's between them. And those are all the rules. Have fun. Okay, sorry. Have fun is the last rule, and we will definitely try. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So, well, for all the parity lines, we know the numbers add up to essentially the length of the line, right? You have a certain amount of digits on one which are odd and a certain amount of digits which are even, right? And they both have to add up to the total number of digits, right? So the end line of this must be either 2 and 4 or 1 and 5. We're not sure which, right? Actually, in this coloring, I'm going to use blue and, well, maybe we'll use, right, for now, orange and pink. Because we don't know which shading is which, right? So the thing is, on this line, you cannot have 6 odd digits, because again, you only have 5 odd digits total in the digits 1 through 9. And you cannot have 6 even digits, so you can't have 6 even digits because there's only 4 digits that are even in 1 through 9. So this has to be 1, 5, or 2, 4, so they have to swap colors once and then swap colors again, because these are going to be the same parity, right? It's either 1 and 5, which are both odd, or 2 and 4, which are both even. And since you can't have all odd digits or all even digits on this line, you're going to have to swap once here to swap from like even to odd, then back to even, or you're going to have to swap, I guess swap twice, sorry. Or you're going to have to swap from odd to even and back to odd here. Now, in yin-yang shading, you can only swap at most 2 times on the edge of the grid. And the reason is, say you had one coloring, say you tried to make this swap multiple times, more than 2 times on the grid. So it swaps here, say it swaps, say we had orange, well, say we had orange here, and then this swapped, and then we swapped again, right? Well, how do you orthogonally connect the orange regions together without breaking apart the pink regions? You can't, right? Trying to get any sort of orthogonally connected shading will break the pink into two because of you're swapping more than 2 times. Same with the pink region. If you try to get a pink region orthogonally connected, the problem is that will break the orange regions into multiple regions, which is not allowed. There's one orange region and one pink region, right? So, because of that, we know that we're going to make this all orange. This, from here to here, you are guaranteed this is all one region because we're swapping once here and then we have to swap another time here to swap back. And we know these are definitely the opposite pair, but we don't know what these are. These could be orange or pink here. This has 4 digits which are the same, so one of these could be 4 or 5. You have to have 4 of one and 1 of the other. So this must be a 1-4 pair here. But we don't know which is which, right? This is pink guaranteed because this 2x2 area has 3 oranges and it can't be all orange, so that's pink. But these are all the same shading, therefore they're all the same parity. So one is going to be 4, there has to be one of the other. This must then be pink. Right? Because you have 4 oranges, the other one has to be different. You can't have 0 and 5 because 0 is not allowed on this puzzle because it's normal Sudoku rules. This is pink. This is pink. Because of the 2x2 boxes. These are 2 and 1 as a pair to add up to 3, which is the length of it. So this must be pink here. This then is a 1, 2. This cannot be 2 and 1. It has to be 3, 4, 6, and 8. Oops. 3, 4, 6, or 8 as a possibility for a 1 to 2 ratio. This is 1, 2, 3, 4, 5, 6, 7. So these add up to 7. We have guaranteed 4 of one color, but we don't know. So it could be 1, 2, 3, 4, 5, 6 on either side. This adds up to, oh, this can't be 5 and 1. Or it could be 5 and 1. Oh, we don't know if this is pink. It could be 1 pink also. Okay. So we don't know this is actually either of these are pink. It could be 1 pink and then all the rest are orange. This is a combination that adds 1, 2, 3, 4, 5, 6. So that also is 1, 2, 4, 5. But this is the opposite, interestingly enough. Huh. So it's got to be the one that doesn't add up with that one. This is 1, 2, 3, 4, 5. This has to be 2, 3 as a pair because we can't be 1, 4 because of the 1, 4 pair in the row. So this is 2 or 3, which eliminates 2 in the rest of the box. So this can't be 2. That means this can't be 4 here to add up to 6. This is 5 also. 1, 2, 3, 4, 5. So it could be 1, 4 or 2, 3 here. This is 1, 2, 3, 4, 5, 6. So it could be 1, 5, 2, 4, or 3, 3. Because the reason why these have to be 1, 5, and 2, 4 are they in the same row or the same box. These are not in the same row, box, or column. So this could be 3 and 3. We don't know. How about here? 1, 2, 3, 4, 5, 6. So this is also the same. 1, 2, 3, 4 cannot be 5 because 5 cannot be next to a black crocky dot because if you have 5, you get 2.5. If you double 5, you get 10, neither of which are digits. So then this must be correspondingly 2, 3, 4, 5. We have 1, 2, 3, 4, 5, 6, 7. So these add up to 7. So it's either 1 through 6 here, and this is 1 through 6. But this can't be 1 or 4 because of the 1, 4 pair in the box. So this can't be 3 or 6 here. Interesting. This cannot, oh, this is 1, 2 pair eliminates 1 and 2 in the rest of the row, so this can't be 1 or 2. This cannot be 4 or 5 correspondingly. This can't be 2, so this can't be 4 correspondingly. 1 is in a 1 to 2 ratio with can be 2. 2 can be in a 1 to 2 ratio with 1 or 4. 3 is in a 1 to 2 ratio with 6. This digit is consecutive with 1, 2, 4, 5. So it could be 1 through 6, but this can't be 1 or 2. So this cannot be 1, because if this were 1, that would have to be 2 to be consecutive with it. So this can't be 1, which means this can't be 6. This can't be 2, because if... Well, it could be 2. Never mind. This is 2, that's 3. If this is 4, this is 3 or 5. If this is 5, that's 4 or 6. Okay. Huh. At least one of these cells has to be pink. But we don't know anything else. This is in 1 to 2 ratio. So we have 1, 2, 3, 4, 6, or 8 here, because that's a 1 to 2 ratio there. Remaining digits of row 2 are 5, 6, 7, 8, and 9. Okay. We are guaranteed 1 and 4 in the rest of row 1, right? Can't be here. The rest of 1 and 4 have to be here on this line. If this were... If this is 1 and 5, this is guaranteed to be 2. So that means 2, and if this is 2 and 4, obviously there cannot be another 2 in the box. So we are guaranteed... There's no more 2 in box 1, right? Because if this is 1, 5, that's 2, which eliminates 2 in the box. If this is 2, 4, 2 is eliminated in the rest of the box. So this cannot be 2. Therefore, this can't be 1, because 1 is only in a 1 to 2 ratio with 2. So this can't be 1, which means this can't be 5. Okay, where is 3 in box 1? It has to be one of these two cells. Okay. We are guaranteed a 3 on here, a 1 on here, and a 4 on here. Okay. If this were 4, that would mean these would all have to be even. And then this would be 1 and 5 at the end. If this is 1, all 3 of these would be odd, which would mean that's 4 and 2 at the end. We have 2 of one parity here and 3 of the other parity here. Oh, this is interesting. What happens... So either this is even, and that's even in this parity line, or this is odd, and that's odd, but that odd would be a 1, which means this could not be a 1-5 pair. If this is even and even, there's no way you can get 5 evens in this line because it's in the same box. So then this would be 2 and 4. If these are odd, if you have an odd digit here, and this must be odd, that means there's at least 2 odd digits here. Hold up, sorry. Let's take it back. If this is even and this is even, that means you cannot have 5 evens in the box on the line, and you already have 2 evens. So it would have to be 2 and 4 here. If you have an odd here, it's 1, which means this can't be a 1-5 pair to add up to 6, so it must be 2 and 4. So you're guaranteed that this has to be 2 and 4 here, which eliminates 2 and 4 in the rest of the box. So this can't be 2, this can't be 4, and we know this has to be a 1-5 pair to add up to 6. So we know the oranges are all odd, and the pinks are all even. But the coloring is not matching. Maybe I should just stick with orange and pink. So this is 1-5, 1-5. That means all of these must be even, because we have 2 odd digits, and we have guaranteed 5 odd digits here. So we know we have 3, 4, oops, I don't know how I included that one. We have 3, 4, 7, 9 remaining. This can't be 3. That leaves this as 2, 6, and 8, which means this is the same parity as that. So this is 4, this is 1 here. So this cannot be 1, which means this can't be 6. This can't be 4, so that can't be 3. This 2, 6, 8 eliminates 2, 6, and 8 in the rest of the box, so this can't be 2, no 6 or 8. This is actually 3, 5, 7, 9, 3, 5, 7, 9. 2, 4 pair eliminates 2 and 4 in the rest of the box, so this can't be 2 or 4. This is 3 with 7 or 9. So these are both odd. And one of these is odd and one of these is even. We're not sure. So this has to be pink. This is 3 or 5, so this can't be 2, 4. It can't be 5 here. So this is 2 or 4, which is consecutive with 3 or 5 here. We have a 3, 4, 5 triplet in row 5 also now, which means the rest of the digits are 6, 7, 8, and 9. If this were 3 and 4... Okay, what does that mean? If this is 2, 3 here, adding up to 5, this has to be 4 and 5. So we cannot have 4 in that column then. Otherwise, this is 1, 4, which means we can't have 4 in the column. So this can never have 4 in the column. This can't be 4. This must be a 4 here. So this is orange. This is pink. This can't be 4 here, which means this can't be 8 here, because it needs to be 8 needs to be in a 1-to-2 ratio with 4. These are both odd. That means we have 3 odds in... Oh, it could be 3 evens also. What are the colorings here? So 2 of them... You cannot have 4 pinks here, because then you would have a 2x2 area that's all pink. So it must be that the oranges are 4. And since we have all odd digits here, The 4 being oranges means the even digits are orange in that line. So this is 2, 4, which means that can't be 1. This is 6. This can't be 5, 6, 7, or 9. It's 8, which means this is 5, 7, or 9 here. And 5 has to, we have a 5, 7, 9 triplet in row 2, which eliminates 5, 7, 9 in the rest of the row. This can't be 5, 7, or 9. It's 6. So these are both pink. The pink has to exit out, otherwise it will not be able to form an orthogonally connected region. 6 is in a 1 to 2 ratio with 3, so this is 3, and this must be 3 to add up to 6, right? 1, 2, 3, 4, 5, 6. So orange has to be the odd digits on that line. This can't be 3. That means this can't be 3. This is 1 or 2. 3 eliminates 3 here. This is then 5. This 5 eliminates 5 here, so it's 4 and 2 to add up to 6. 5, and it's only consecutive with 4 here, so this is 4, this is 3. That eliminates 3 in the rest of the box. This cannot be a 1-4 pair, therefore it's 2 and 3, and this 2 eliminates 2 here. So this is 3, which means it can't be 3, that's 2. This eliminates 2, 1, 2, 4, and 3, 6 as possibilities for the 1 to 2 ratio, so this must be 4 and 8. This can't be 8 because of 8 in the column, so this is 4, which makes this 8. 8's consecutive only with 7 or 9, so that's 7 or 9. This can't be 6 or 8, it's 7 or 9. Let's see. 2 is even here, so this must be even here. That's 6 or 8. Remaining digits in row 8 are 1, 5, 6, 7, 9. Not 8. 1, 5, 6, 7, 9. That means this can't be 1 because of 1 in the column. Two of these are one color, and 4 of them are the other color. What are the okay, where is the 2 in column 1? Can't be here because of 2 in the box. Actually, this 2 eliminates 2 here. So this is 4, this is 2. And 2 can't be here because of 2 in the box. So 2 can't be here because of the 1-2 pair in the row, so 2 has to be here. So the evens are orange on this line. Okay. That means there are 4 oranges on this line. This has to be pink because of the 2x2 area here. This must be pink because of the 2x2 area. And the pink has to exit out here to be orthogonally connected. Same with this. This must exit out. So this is orange. We have 4 oranges on this line. Pink has to exit out this way. These are both pink. One of these is pink, one of these is orange. We're not sure which. So these are odd digits. So 1, 3, 5, 7, 9, but this can't be 3 because of 3 in the box. This is even. It's not 2 or 4. It can't be 8, so this has to be 6. Which means the remaining digits, so this has to be an odd digit. So it's 5 or 7 to be consecutive with 6. Remaining digits in box 7 are 1, 3, 5, 7, 9. This can't be 3 because of 3 in the column. So these are all odd. We have even, even. This is odd. So these are orange, so these both must be pink. And one of these is odd and one of these is even. We're not sure which. Same with this. One of these is odd, one of these is even. Aha! Here we have a diagonal, which is all pink. So aside from the only being able to swap colors twice on the edge of the grid for yin-yang, anytime you have a diagonal of the same color, the other diagonal has to be one of that color and one of the opposite color. Obviously, it can't be one. It cannot be four. If they were both the same color as the pink, then you'd have a 2 by 2 area that's all pink. But how do you? What happens if you have an orange here and the pink here? Well, how do you orthogonally connect this orange region to the other to this part without breaking the pink region into two different regions? You can't. Same with a pink, right? Therefore, that's why you know anytime you have a diagonal of the same color, you must have one color on one side and one of the same color on the other side. So this cannot be two oranges, and therefore this must be pink. And we have three pinks already on this line, so this must be orange. Pink has to exit out, so it has to exit out that way. So this is odd. This cannot be 6 or 8, it's 7 or 9. We have a 7, 9, 7, 9 pair in row 5, which eliminates 7, 9 in the rest of the row, so this is 6, 8, and it eliminates 7, 9 in the rest of the box, so this can't be 7 or 9 here. These are all even. So this has to be a 6, 8 pair, because the oranges are odd. So this cannot be 2, 4 either, so this is 6 or 8 also. Let's see. So 3 eliminates 3 here. This is 2, which eliminates 2 here. This is 3. So this has to be orange, and this must be pink, because the evens are pink here. And if this were 3 oranges, well, you could go exit out pink that way. Okay. Remaining digits of row 3 are, you could have 5, 7, 9, and you have to have, or you could have 1, and you have 8. But where is 1 in row 3? It has to be one of these cells. So this can't be 1 here. This is 5, which forces this to be 1 here. That eliminates 1 in the rest of the column. So this can't be 1 here. That means in column 1, 5, where's 5? 5 has to be in one of these two cells, which eliminates 5 in the rest of the box. This can't be 5 because of 5 in the... These can't all be 5 because of 5 in the row. Sorry, 5 in the box. So 5 in row 3 has to be one of these two digits, which means this can't be 5. So this is 7 or 9. 6 eliminates 6 here, so this is 8, which makes this 6. These are opposite colors. If you had an orange here, that would force pink to be there. And then you'd have that diagonal cross thing of the same colors. Different colors being on the same two of the same color being on the diagonal, with the opposite diagonal being the opposite color, which is not allowed. So then this must be pink and pink. This must be orange and orange. Since pink is even on this line, that means orange must be odd. So this is orange. We have orange, orange here. That forces this to be orange here. So this must be odd. So this is 1, 7, or 9. Pink has to exit out to orthogonally connect to the rest of the pink. So this is pink. We have this is 6 or 8. This is 6 or 8. So this is even, so this must be pink also. We have a 2 by 2 area that's all pink so far, so this must be orange. We have a 2 by 2 area that's 3 orange, so this must be pink. Pink has to orthogonally connect, so this must connect that way. we have a 6, 8, 6, 8 pair in column 4, which eliminates 6 and 8 in the rest of the column. This can't be 8. This can't be 6. So this is now odd, and this is odd. And therefore, this is orange here, because oranges are the odd digits on that line. And this must be pink, because these are... pink is the odd digit on this line. That means we have a 2 by 2 area that has 3 pink, so this is orange. Pink has to orthogonally connect, so that's pink. And these can't... we have a 179 triplet in box 2, which eliminates 179 in the rest of the box. This can't be 17 or 9, it's 8. Remaining digits in column 5 are 179. Okay. We have 3 odd digits here, 2 even, 1 odd and 1 even here. So this is 1 odd and 1 even here. Okay. That's not very helpful. We have 3 odds already here. We have to have at least 1 more pink. It has to be 1 pink and 1 orange here in some combination. Because it can't be 2 pinks here, because that would make 2 by 2 area that has 4 pinks. That's all pink. And again, we need 1 more pink on this line, because we only have 2. So we have to have 3 at least. So one of these is pink, one of these is orange. We don't know which is which. You cannot have 1 and 6 here, because if you had 1 and 6 here, the problem is you'd have 6 of an even digit or 6 of an odd digit, and that's not allowed in the same box. So no 1 and 6, and also you have a 6 here. Interesting. We have 4 odd digits in row 7 already. And we're guaranteed one of these digits is odd because it adds up to an odd digit. And you have to have an odd and an even number for 2 digits to add up to an odd digit. So that means the rest of the digits are even. So this is 2, 4, or 8. 2, 4, or 8 here. This can't be 2 because of 2 in the box. So we're guaranteed 2 has to be one of these 3 cells. Because you can't have a 2 here because of 2 in the box. You can't have a 2 here because of 2 in the box. Interesting. If this is 2, this would be 3, 3, and 4. And that would work because 2 would guarantee you don't have 4 evens in this box. Okay, yeah. So what are the possibilities for this? Either this is 3 and 4 and this is 2. So 3 and 4 would work because 3 would be odd here. And, sorry, yeah, 3 would be odd. We'd have 4 odds and the remaining 3 evens would be here. Or you have 2 and 5 as a pair here. And to be 2 and 5, you can only have 5 odd digits. You can't have 5 even digits because there's only 4 even digits in a box. Because the digits 1 through 9, you can only have 4 evens, right? 2, 4, 6, and 8. So if this is 2 and 5, then this has to be 5 because we have 5 odd digits in the box. And these are already 4 oranges. So either way, this is an odd digit. Which means this can't be odd. This is even. So this has to be pink. This can't be even. It's odd. We have 1, 3, 5, 7, 9 here. 1, 3, 5, 7, 9 here. The remaining we have 5 odd digits in row 9, which means the remaining digits are even. So this has to be 2, 4, 6, 4, 6, or 8 here. And this is 4, 6, or 8 here. Well, 1 cannot be here because 1 is only consecutive with 2. Otherwise, this works fine. This is even. So we know these 3 are all even, which means this cannot be 3 evens and 4 odds. It has to be 2 evens and 5 odds. So this is 2, this is 5, because this has to be even here. That eliminates 5 from the rest of the box. And we have the 2 evens here, so this must be 6. Oops. This is 6. So this cannot be 6 here. This cannot be 2 here. This must be odd, so it's orange, which means the pink to connect has to go out this way. This can't be 6. It's 7, 9. We have 1, 3, 7, 9 here. Where is the 3 in this box? Can't be here. No, can't be any of these cells, so it must be one of these two, which eliminates 3 in the rest of the row. So this can't be 3. Where is the 3 in box 7? It has to be here. So this is 3. We also have a 5, 7, 9 triplet in box 7, which eliminates 5, 7, 9 in the rest of the box. This can't be 7 or 9. It's 1. This 3 eliminates 3 here. So we have to have a 3. We have to have a 7, 9 pair in column 2, which eliminates 7, 9 in the rest of the column. This can't be 7 or 9. It's 5. This is now a 3, because that's the only place for it to be in box 1. And this 5 eliminates 5 here, so it's 1, which eliminates 1 here. This 5 eliminates 5 here. So we have a 7, 9 pair in column 3, which eliminates 7, 9 in the rest of the column, so this can't be 7 or 9. It's 5. 3 is one of these two. 1 eliminates 1 here. Where is 1 in box 9 then? It has to be here. That eliminates 1 here, so this is 2, which eliminates 2 here, so that's 1. So oranges are even, so this cannot be 3 here, which means this can't be 6. Where is 4? Well, we don't know. Where is 3 in row 6? Cannot be here because of 3's in the boxes. Can't be here because of 3 in the column, so it must be here. So this is 3, this is 6. That means we have to have a 4 somewhere in, and this 6 eliminates 6 here. So this is 8, which eliminates 8 here, so it's 6, which makes things that can't be 6 here. This is 8, this can't be 2 or 8, it's 6. This can't be 2 or 6, it's 8, which forces this to be a 2 here. The 5 here eliminates 5 here, whereas the 5 in box 3, it has to be here. Again, where's 4 in row 6? Can't be here because of 4's in the boxes, and these are filled out. So this must be 4 here, and therefore must be pink. And we have 3 pinks in this 2x2, so this can't be pink. This is orange. We have an orange on a diagonal here, so this can't be 2 pinks here, so this must be orange here. We have a 2x2 that's all orange. This can't be orange, that's pink. We have a diagonal that's pink here, so this can't be orange. This must be pink. Also, the pink has to orthogonally connect. We have a 2x2 area that has 3 pinks, so this can't be pink. This is orange. And we need to fill out these according to their odd and evens. This has to be odd. It cannot be 1, 3, or 5, so this is 7, 9. This is odd. This 3 eliminates 3 in the rest of the column, so this can't be 3 and 4 adding up to be consecutive. So that leaves this digit as a 5. And so now the remaining digits can we just do from Sudoku. We have a 7, 9 pair in box 9, so this can't be 7 or 9. It's 3. That we also have a 7, 9. That's 3 in the corner. We celebrate because we know we're close to solving it. This is 7 or 9 here. And this must be 7 or 9 here in box 6. The remaining digits in row 4 are 1 and 2. 2 cannot be here because of 2 in the column. So this is 1. This is 2. We have a 7, 9, 7, 9 pair in column 5, which eliminates 7, 9 in the rest of the column. So this can't be 7 or 9. It's 1. This can't be 1 or 6. No 1 here. Where this 5 eliminates 5 here. So this is 7. This can't be 5 or 7. It's 9. That eliminates 9 here, so it's 7 and 9. The 7 eliminates 7 and 9 here, so this is 5. 9 eliminates 9 here, so it's 7, which eliminates 7 here, so that's 9, which makes this 7. So this is consecutive only with 9, is 8. So this is 8, this is 6, this is 4, this is 8, which makes this 4. And the rest is normal Sudoku. This can't be 7 either case. This can't be 5 because of 5 in the column. So this is 9, which makes this 5. 9 eliminates 9 here, so it's 7 and 9. This can't be 7 or 9, it's 1. And this can't be 7 or 1, it's 9. 9 eliminates 9 here, so it's 7, which makes that not 7. So it's 9, which makes this 7, which makes this 9, which makes that 7, which makes that 9. And therefore, this is a 7. And that's the solution. Very cool, actually. Very interesting rule set here. Where you have the different shadings, right? So it uses yin-yang restriction quite a bit, which is good. And it also restricts based off of the endpoints, right? For each parity line, which is also fairly interesting. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.